Thank you all for coming here tonight. I know it's a Sunday night and you probably had other plans, but as Stephen mentioned in the chat today, Git and GitHub are like essential technologies to know if you're going to be coding and collaborating with people. So I'm really excited to talk about that today because I use this every day in my own work and projects. And so yeah, just to give you a little background on me, my name is Claire and I'm in the US right now, but I just graduated a coding bootcamp in Montreal in Canada for full stack web development. And so we used Git and GitHub a lot because we were collaborating on our projects. I still use it every day, and I'm very excited to tell you guys about it. So without further ado, what is this Git we're talking about? So Git is like formally defined as a distributed version control system, which is really like a fancy way of just saying software that tracks changes that you make in your documents. It's free and open source, and it's really popular with coders, as we'll see, because just talking about documents in general, have any of you guys ever written a report for school and had okay, document version 1, you make some changes the next day and you save it as version 2. Your friend reads over it and notices some typos and you make it version 2.1 and blah, blah, blah. And you're finally almost ready to submit your document to your teacher and you're oh, which one is the final version? I don't know. You have 10 different documents in your folder. So Git is kind of trying to alleviate that pain by letting you control your versions as one master version, and it tracks all your changes. So why is that popular with coders? Essentially, we're just working with documents, guys. It's like text most of the time, right? These Python files or HTML files. And your projects likely have more than one document. So you can imagine how even tracking one document can be kind of a mess, but imagine tracking 100 documents, and imagine tracking 100 documents not just with yourself, but with several other coders. So that's why we need Git to kind of keep us organized. So why do we need Git? It's to avoid those versioning conflicts we were just talking about. Git allows us to know who made what changes to our documents and when. And it also lets us revert back to older versions of our document if we want to. For instance, if we add a new feature to our code and commit it to our master version and suddenly some parts of our website stop working. Git allows us to revert that last change and not have to go through each file one by one trying to remember the parts that we changed. And just with one command, you can go back to the working version. So overall, Git helps us debug and add new features without breaking our master code. Anybody can install Git for free, and I'm going to share these slides in the channel afterwards so you guys can use these links. But basically, if you're on Mac, you just do a brew install Git. On Linux, you do a sudo apt install Git, and Windows, you have to just download Git from the website. So there's 2 nouns that you absolutely must know if you're working with Git, and that is commits and branches. And a commit is kind of just another way of saying a save. When you save your document, it's kind of you've committed those changes, you want to keep them. When you exit the text editor, you're going to open it again and you're going to have that, most recent version of your document. So you'll see here, there's a lot of different colored dots. They're all on different lines. And each of these lines is called a branch. By kind of convention, the main, most current, recent version of your document is going to be on a branch called master. And anytime you add a new feature, you're going to make a new branch, and you'll make separate commits on that branch, and eventually merge it back into your master branch. So these 2 nouns, a commit is like a save, and a branch is just a collection of commits. We're going to be working with Git in the command line, which is the cool coder way to do it. There's also graphical user interfaces out there that you can download a Git GUI to help you click around and do Git. But the real coders, they do it in the terminal. And when you're in the terminal, we're going to need to be using some commands. So kind of the important ones I'm going to point out are these red ones we'll be using today. You only run this once at the beginning of your project. And then whenever you've made some changes in your code, you're going to stage your changes for commit by running git add. And when you're finally ready to commit to those changes, you're going to use git commit. And at any time, and it's always good to use this, especially when you're starting with Git often, you can run git status and it will tell you, okay, you have some changes that haven't been committed yet. We recommend you commit them or you're going to lose them or there's going to be conflicts. So git status is a really important command just to kind of know where you are in your Git. There's also git config, which is how you set up Git initially. Git branch is how you list all of the existing branches. Git checkout, also known as git co as a shorter hand, lets you switch between or add branches. So when you want to add a new feature, you'll use git checkout to create a new branch. And you'll make all your commits on that new branch, and then you'll git merge them back into your other main branch, like master. And finally, there's a command called git log, which you can type in, and it will just show you like all of the commits that have been made in your project, by who and when. So to kind of visualize like the basic flow of Git, let's say that this blue line here is our master branch. Okay, and you can see this master branch has a past and a future, but at this left-hand dot, we're typing git checkout -b, and we're going to make a new feature. So we call this branch new feature. This git checkout -b is the shorthand for creating a new branch. Okay, so after we've typed this, we're now on the new feature branch, this red branch. So while we're in this branch, we're going to make some changes, and then we're going to add those changes, which is the shorthand for staging them for commit. And then we'll type git commit -m and type a short message that describes the changes we just made. So this m is short for message, and this whatever is in between your quotation marks is going to be kind of like a mental note to yourself and other people of what was actually changed in the code. Just a really short description. It will help you kind of remember what was changed. Okay, and you can do this as many times as you want. Like say you add some more changes, you're going to git add again. Then you'll also commit and add a message about what was changed in that case. So in this case, like add title or something. All right, so you've made all the changes and you're ready to incorporate them into your official like master version. So what you have to do is git co master, which is short for checkout master. It's how we kind of switch the railroad tracks back to our master branch. Now we're actively in the master branch. So from master branch, we can now git merge the new feature branch that we were on previously. And it's going to take all of those changes and commits and merge them with the master branch. So in this whole process, we were always safe. Like if we made some changes and they didn't like them, we could always throw out this new feature branch and it would never like dirty our master branch. But so the kind of key things here, like you only merge things that you know aren't going to break your code, and you want to commit them to like the canon of your project. So before we talk about GitHub, we're just going to do kind of like a live demo of Git flow. To do that, we're just going to make like a simple HTML document. So I'm going to switch over here to my terminal. All right. So remember how I said the first step was installing Git? Since I use Git every day, I have it. So that's why it's green when I type it in. You can check and see if you already have Git by saying git -v or version maybe. There. And if it comes back with a version, you have it. If it doesn't, then you need to install it. So like I already have it, but if you didn't, you would do like brew install git or something on your Mac, apt get install for Linux. But once you have it, like I do, you're ready to go. So we're going to make a new project, and we're going to call it Square Zoo. All right, so in here we have a new project. We'll cd in there to Square Zoo. Okay, and you'll see that this is empty, so we're going to make a new index.html. Okay, and I use the text editor Atom. Maybe some of you use a different one, but they all pretty much work the same. So here we are, we've got our empty HTML file, and I'm just going to quickly scaffold out some HTML, and here we go. I'm sure you guys are familiar with the basic HTML, but even if you aren't, that's cool. The whole point is just to see how changes are saved and merged. So we'll call our document Square Zoo, and that's it. So we haven't actually run Git. And so remember I told you there's this one way to start the project, and that is git init. And now you'll see down here, it initialized empty Git repository in the location that we're at. And you'll notice also there's this funny thing down here, it said Git master, because it's showing which branch we are actively in. And when you init, you are automatically in the master branch. So if we look at our project folder now, and we look at the hidden files, we can see that there's now one called .git in here. It's a hidden file, but this is where all of our changes are going to be tracked by the Git system. You can actually see it here in my text editor. There's a ton of stuff. You don't have to ever open this or look at it. It's going to be kind of a lot of numbers and letters. Forget about it. But it needs to be there to track our changes. Okay, so I'm kind of lost. We're in the terminal now. I don't know like where we are in terms of Git and saving and all of that. Remember, you can always check what's going on by saying git status. And it says when I do that, that there's some untracked files. You see this red text in index.html. It's because I haven't added this file to our Git tracking yet, even though it's been added to the project. So the way to add it is we can do git add, and then you can say index.html, and it will add this file to our tracking. So now what happens when we say git status? It's green now. It says there's some changes to be committed because git add is how we stage changes. And that means we're ready to commit it. So I'm going to go ahead and just say git commit. And this is how we add the message. You say -m. And it's kind of conventional just to say like initial commit on your first one because there's really not a whole lot of change going on. It's just starting your project. So now that we've committed, we can check again our git status. And it says on branch master, nothing to commit, working tree clean. So this is all good. We're all caught up to master. There's nothing that's, no changes that are outstanding that haven't been added for commit. Okay, so let's say we want to actually add some content to this because I can open this right now in the browser. And it's going to just be a blank page, I'm sure, yeah, because we have nothing in here. So let's put some stuff on the screen, maybe like a title, like welcome to the Square Zoo. All right, so now if we refresh it, it show up here. And that's a change to our document, right? So we can do git status again and see what's changed. And it's going to say, okay, index.html was modified. So I'm going to go ahead and just git add it again. And before we had typed git add index.html, the specific file. Sometimes you might have changes to several files. You can type them in separately, like index.html, like file 2, blah, blah, blah. Or the kind of shorthand to say like add all of the unadded changes is just to say dot. So git add dot is going to add anything that's been modified but not yet added. We can do that. So check again, git status. Okay, it's modified, it's green, it's ready to be committed. So I'm going to say git commit -m add title. All right, so git status again. We're clean. Nothing has been changed. Okay, still a pretty boring website. So let's actually add some squares to our zoo. And we're going to do that by adding it like as a new feature. Because so far we've only been working directly on the master version of our project, the master branch of our project. And we want to add a new feature, add some squares, and we don't want to break our project. So we're going to do it safely by checking out to a new branch. So we'll do git co, which is short for checkout, -b, which means checkout to a new branch. And then we just give it the name of the branch. So we're going to say like add squares. You can call it anything you want. And you'll see down here, our active branch is now add squares. Let's actually add our squares. So we'll make 2 divs with a class square. Make 2 of those. And we're going to just add some CSS so that they show up on the screen. So we'll make a new file called style.css. And we'll have to, of course, import our style sheet here. So style.css. And we'll take this square class and give it a height of like 100 pixels, a width of 100 pixels, and background color red. Okay, let's see what happens. Great. It's showing up something on our screen. Let's add a little margin to that as well. So there's some space. Okay. So we've got some squares in our zoo. And now I want to commit this to our branch and then finally merge it into master. So let's check out our Git status because we made some changes. It says that we modified index.html because we added these 2 lines. And we also have an untracked file, this new one, style.css, right? Because we just created it newly. So we can just use our handy dandy dot to just add all of these to stage for committing. We can add git status again to see how it's going. You'll see this green is good. It means it's ready to be committed to our add squares branch. So we can say git commit. And we'll say the message with like add 2 red squares. Voila, git status. This branch should be now clean. So you only want to kind of move between branches when you have this clean status. Because if you start moving around branches with like unsaved commits, it's a great way to trap yourself in kind of like versioning confusion and conflicting code. So always aim to be on a clean tree. Okay, but we're still in add squares. We want to merge this into our master. The way to do that is we have to first check out to master and make that our active branch. So now we're in master, and you'll notice that all of the code disappeared that we had just done, right? And actually style.css is gone too, because master in the past didn't have these. This is all added by the add squares branch. Okay, so how do we get that back? Remember, we do have this branch floating out there. We could say git branch, and you see add squares exist as a branch. We want to pull that branch and merge it into our master branch. So while we're in master, we can say git merge add squares. And it tells you exactly what was changed. It says, okay, in your index.html, you added 3 lines of code, which is these guys. Maybe they're, oh, and we also added this, right? So 3 lines of code. And in style.css, you added 6 lines of code, and that's what these 6 lines are. So basically, Git is all about addition and subtraction of lines. If you deleted a line, it's going to have like a red minus. If you added a line, it's going to have a green plus. And this way, you can see exactly what was changed and where. So this is great. That's like the basic Git flow of adding a new feature without corrupting your master branch. Let's get back to the slides. I saw that some of you have heard of GitHub before. And I'm not surprised because GitHub is kind of like one of the essential tools many coders use to collaborate and share their code. Like its name sounds, it's essentially a hub for your Gits in the cloud. So it's used by like over 40 million developers in the world. You can tell that it's a very useful product in that sense, and it's free. We can go take a look at it. This is GitHub on the inside my account, and actually it's kind of like Facebook. It has a news feed. You can see what other coders have done recently on your friends list, and I see Steven did some things. But you also have like a profile like you would on Facebook, and it has like a bunch of your repositories. We'll talk about that in a second. It has all of the changes that you've pushed to GitHub recently. So it's just a website in the cloud that you can store your code in, essentially. Why should you use GitHub, or why would you be interested in using GitHub? One important thing not to overlook is that it's a way to back up your code, because all of your code that you push to GitHub is in the cloud. So say you spill coffee on your computer tomorrow and you lose all of the like lessons and projects that you've been working on. That's a nightmare. If you had pushed it all to GitHub, it's always there and you can access it from any computer in the world. Another huge important feature of GitHub is its ability to help developers collaborate. You'll see like, all open source projects are, not all of them, but like many people use GitHub for their open source projects because anybody, you or me, can go into their project, take all their code to my computer, do some changes, and then push it back up there and request that they adopt our changes. Same thing, like if you have your code up there, somebody else might see it and like find a bug or like want to add a cool new feature. They can do that through GitHub. Of course, they can't change your code like without your permission. Like you always have the final say of whether you want to accept their change or not. But it's really a great way to collaborate. And then lastly, it's a way to showcase your work, because if you have public code on GitHub. Anybody can see it. So like if you're looking for a job, like employers might want to see how clean your code is, or if you have like a really cool project that you're proud of that you want to show off to somebody, you can even host it on GitHub sometimes. So it's a great way to showcase. This image down here shows like how many commits that you've made like that were pushed to GitHub in the last year. And some employers like to see like lots of green on here. It means you're an active coder, like coding almost every day. Or it shows like how, committed you are to coding by how many commits you make. How do you get set up with GitHub? Well, you've already installed Git on the computer, so you can just go over to Git and make an account. And then you do like the first time config to like link your GitHub account to your local computer. And I'm not going to do that in today's tutorial because mine's already set up, but the link here will guide you through that. Before we move forward, I just want to tell you a couple of Git terms that you're going to hear. The first one is repo or repo. It's short for repository, which is essentially just a place where you put your code. And you're going to have like local repos, which are the ones that are on your computer, and a remote repo, which is the one that exists in the cloud in GitHub. And to go between like the remote and the local repos, you'll use a Git command called git push and git pull. So git push is how you upload your code to GitHub, and git pull is how you download code from GitHub to your computer. You also hear a term called cloning, which is just taking a copy of a remote repo in GitHub and pulling it locally to your computer. So you're going to clone something, like if you want to add a feature to somebody else's project, you're going to clone their project to your computer, and you'll make the changes, and then you'll push it back up to GitHub. And after you push it back up to GitHub, you can make a pull request, which is like asking permission to the person that owns that repo. It's like, hey, I have some changes I think would be great for your project. I'm making a pull request. Please take a look at it. If you like it, you can accept, and it will merge their code into their repo. And lastly, there is something called forking, which is sort of like cloning, except it's kind of remote to remote. So like inside if you find like a cool project on GitHub and you want to extend it, like you found like a game and you want to change like the sprites and the characters or something, you can fork their project, which will make a complete copy of their repo and put that code inside a new repo in your GitHub. Okay, so still we're going to be using Git in the command line today, but we're going to be interacting with GitHub instead of just locally on our computer. So there's a couple extra commands to be aware of. One is the git clone, where you can copy, like we said, the remote repo to your local computer. We're going to be using git push to push a local branch to remote repo. Git fetch is how you just get code from GitHub, but git pull is kind of like a combination of git fetch and merge. So you'll fetch the code and you also merge it to the current branch that you're in. So to illustrate this, I thought we could just fix a bug in one of my websites that I noticed recently. I published a children's book a couple weeks ago called The Power of Vegetables, and it's available in a couple languages, including Japanese. And I was looking at the Japanese version of my website and noticed that there's a translation missing in the books page. So you'll see here, it's like Kindle, something Japanese, Kindle, and paperback. I want this to be in Japanese. I noticed there's a line of code missing in my project. So we are just going to go live and change that and actually make it change on my website. So let's go back to our terminal. We're going to leave our Square Zoo. Bye. And I need to get into my, I think it's this. Yeah, okay. So this is the code on my computer that is related to my website. I'm going to open it in the text editor. We're on master branch, as you can see. And this is actually the file that I wanted to change. Like, for your information, this project is made in a JavaScript library called React. Maybe you've heard of it. You don't have to know React. You just have to know I'm going to change a line. Basically, you'll notice I have a couple book cards, and that's what was represented in each of these is a book card. And it's missing one attribute in my code. You'll see that it has render language Japanese on these two, but not on this one. I need to add that line to my last book card. So this is such a small change. Normally, I would just make it on master and push it right away. But since I want to show you guys how the pull requests and stuff works, we're going to actually make a new branch. So before we branch out, just make sure we're clean. We can do git checkout -b, which is how we make the new branch. And we'll just say like fix translation bug. Okay, you'll see now we're in the branch called fix translation bug. And the only change I want to make while we're here is just taking this line and adding it down here. Okay, and in order to see that change, I think we have to do this, just so I can run a server and see how it looks before I actually push it. It's always good to test your code before you commit it to master. Let me just check and make sure that, okay, my server is running. I'm just gonna go in here and do a little localhost. I think it's 8,000, yeah. Okay, and go and change the language to Japanese. And that is not me farting, that's my website farting. It's part of the book. Give it a read if you're curious. Okay, and remember how this was English before? Now it says Japanese paperback. Perfect, so the change is good. I'm confirming that I want to commit that. So I'll go back to here. We can do git status and see what's changed. So we modified the books file, but we want to add these changes. So git add, even though it's one file, I'll just say all. So git status. Okay, this has been modified. It's ready to be committed. So git commit -m. And what did we do? We fixed the missing translation for paperback. Okay, cool. And so how are we going to get this into our GitHub code? Because right now, all of this has happened locally on my computer. But I have a repo, a remote repo on GitHub. This is GitHub. It's an exact copy of the code that we were just working on. And how do I get my code on my computer back up here? So when I started this project, I had to do a little config to make sure that my GitHub repo on GitHub was linked to my GitHub repo locally. It has the same name, Power of Vegetables. So it's all set up. And you can see here, if I do like git remote -v, which is like to view all of the remote connections, you'll see I have something called origin that is kind of a nickname for this, which is my GitHub repo, okay? And there's two things in here. There's a push and a fetch. So basically, if I want to take any of my local code and push it to GitHub at this repo, I'm going to use a command called git push. So git push, and what's the name of the destination? It's called origin. So git push origin. And what am I trying to push is the next argument. It's going to be, I'm trying to push this fix translation bug branch. So we put the name of the branch. This is going to push fix translation bug to origin. And it's going to ask me for my password, because not just anybody can be pushing up there. All right, so it does all this stuff, blah, blah, blah. Okay, looks like it worked. And actually, if we go back to GitHub, it says your recently pushed branches. So we did this all in the terminal from our computer, but immediately the website updated and says, okay, there's a new branch. You should check it and see if you want to merge it to your code. So I'm going to click compare. I think you can even see like what was changed. Let's see. Oh yeah, if you scroll down, you'll see there's like a summary of all the things that were changed. So you'll see that added a line on line 44 in this file, renderling JA. I can review these changes, like, okay, yeah, these are the ones I want to commit. And I can write about it. There's not a lot to say. I think this title is enough, fixed missing translation paperback. And you'll see up here, it says compare fixed translation bug with master. So this is the difference with master. And it's available to merge. Like merging this code is not going to conflict with anything in master. So I'm safe to go ahead and create a pull request. So remember we learned this word earlier. It just means like it's a request to have your code merged into master in our case. Okay, so there's one more step. So now you have to confirm. All right. So I'm going to say, all right, I'm ready to merge this change. And I'm going to confirm it again, because you got to be super sure. All right, and now it says pull request successfully merged and closed. You can now safely delete this branch. Okay, I'm going to go ahead and delete it. Never going to use it again. So yeah, you can actually go back into your repo. So this is the Power Vegetables repo, and you'll see this text over here is actually those messages that we've been typing in our commit. And we just did something in this folder, and you'll see that the most recent change was fixed missing translation for paperback 4 minutes ago. So this is wonderful. Like, of course, I'm working on my own project, but if one of you wanted to add something to my website, you can go ahead and, clone it and make a change, push it up here, and make a pull request, and I can review it and decide whether or not I want to add it. So that's kind of the beauty of how collaboration works on GitHub. All right, we're almost done, and I want to leave time for question and answer, but there's one more thing I want to talk to you guys about, and that is what happens when there are conflicts or mistakes, because you can imagine when you're working with, especially with many different people, they're going to be editing the same document, and they might make different changes to the same document that don't merge cleanly, right? So we have to know how to handle those. Basically, what we just did when we merged the fixed translation bug branch to master is it said there were no conflicts, but in some cases there are. And when there are, it's going to Git and GitHub will tell you exactly where the conflict is. And for example, this is just some file that I pulled off the internet, but you'll see there's this weird notation like chevron, chevron, chevron head, and chevron, chevron, chevron test. This is the name of a branch. And you'll see this blue highlighted code is somebody's change, and this green code is somebody else's code that it doesn't merge with well. There's kind of overlapping changes. So what you do as a developer in this case is you look at this whole section, you decide which parts you want to keep, and you'll just erase these weird syntax. So you get rid of the equal signs and the chevrons, and then you'll have kind of the conflict resolved version of your code. Then you'll just do the normal Git process of git add, git commit, and then git push, pull request, all that kind of thing. So that's what's really nice about Git, is it will tell you exactly where there's conflicts, so you know how to fix them, and it keeps your master clean. Okay, so as you can imagine, especially since a lot of this is happening in the terminal, it's really easy to make a mistake, forget to add something, forget to commit something. I've done it a billion times. Even today, I make a lot of mistakes. So there's a lot of websites out there that are dedicated to fixing Git problems. And one of them is dangitgit.com. I've provided it here in English and French. But don't fear. The best way to learn Git is to make these mistakes and then learn how to fix them, because then you feel confident that you can get yourself out of any Git problem. Okay. And there's one last thing I want to mention. GitHub is not the only hub for Gits out there. There's a couple other available kind of repository collaboration websites. One of them is called GitLab. Another one is Bitbucket. They all use the same underlying Git technology. So once you know Git, you're able to use these guys. But for all intents and purposes, GitHub is a really great website. It's free. It's open source. Recently, it's now free to have private repositories on GitHub too, which is great, because if you have code that has sensitive data or something in it you don't want to share, you can still back it up to GitHub. Yeah, and there's a couple of extra guides in here that you guys can check out after I share this in the channel later. So that's all I have to say about Git and GitHub, but I'm really curious to know if you guys have any questions. I think I saw one in the channel earlier. So Tony, or Tones, says, can you view the commits from before? Yes, you can. Actually, there's that command called git log, and it's going to show you the whole entire history of all of the commits. Actually, we could try it in here. Git log. You'll see all of the commits I've ever made in my website, and this is just a truncated version. If I press enter, it's going to say all the changes. It's over 100 commits I've made on this website. But the cool thing is you can see exactly what was changed. Here, who changed it? I did. When did I change it? this date. And what did I change? This is kind of the -m. So all of your changes you can see in here for all history. And that's why, of course, it's attractive to coders, but a surprising fact is like people outside coding also use GitHub. And I don't know, do you guys know like Washington, D.C. in the US? It's like a district. And they publish all of their laws to GitHub so that the public can view the laws and see like when they've been changed. It's like the official way to look at laws for the public. So GitHub is not just for coders, it's also for documents. Can you run an HTML file straight from GitHub? That is a fantastic question. Actually, yes. GitHub has this really cool thing called GitHub Pages. So this is a project I made that has only HTML and CSS. And actually, this is kind of a cool thing that GitHub does is like each of these colors represents a different type of language. And it tells you, okay, this is like 58% JavaScript, CSS, HTML. When you're working like with this stack, that's just like a static HTML page, you can host it on something called GitHub Pages. So you go to the settings in your GitHub repo, and you can go scroll down to GitHub Pages, and mine's already set up, but it lets you click one button and it sets up a GitHub page, which is actually hosting for free your code. So like anybody can go to this address and actually try out your project, which is really awesome. So yes, you can host HTML files on GitHub. Okay, you can put images on Git, right? Because if I watch a YouTube video using sprites, they say go to the Git and download the file. Exactly, yeah. So there's nothing fancy about GitHub because it's just a repository is a place to store your files. And like, we can even go ahead and take a look at, we can go back to that Power Vegetables one because I use a lot of images in that. And like you mentioned, image files are just files. You can check it out. In my static folder, we got images, even sounds over there. But let's say like it's some animals and Papa Deer. And you can click and you can see that the image is here. So you can view images, you can probably hear sounds. I haven't ever tried it. But that's the other thing I wanted to mention. You can click through all these files without downloading them to your computer, and you can actually look at the code right here in the browser, which is cool. Recently, I built a website. I did a freelance project with a partner. It had like thousands of commits. Let me see if I can find it. It's a private one now, so maybe that's why it's not showing up. And so this is an example of one where there's like 3 people actually committing into this project. And you can go to this thing called like Insights in GitHub. And you can actually see like, I think it's not working now because it's private. Let me go to a different project that had multiple contributors. Well, I think that's the only project I had with multiple contributors, but basically what I wanted to show you is like, you can see who contributed what and how much. In this case, it's just me, but you can see like, okay, like from April 19th to June 7th, there was like this kind of graph of commits going on. You can see like, okay, I've added 16,000 lines of code. I've taken out almost 1,000. It's really cool, and all this happens automatically thanks to Git. I will tell you, like, if you're planning to like use coding to like find a job sometime, like really GitHub, getting started early on GitHub is a great way to show like all of this work you've been doing. Like even if you're doing tutorials, I like to also push them to GitHub just to like show when I'm looking for a job that like I'm always constantly working on coding. Yes, you can do Unity and C# on GitHub. You can do any file type you can add to GitHub. It doesn't even have to be code. So do you recommend using GitHub Desktop, or is it the same as the browser version? So Zcoder makes a point that there is a graphical user interface that GitHub lets you download. That's kind of like a point and click way of doing git add, git commit, and all that. And I've downloaded it before and tried to use it, and I think if it helps you understand the concepts, go for it. To me, actually, it was less confusing to do it in the terminal in the end. And that's kind of like I don't want to say like the cool kids way to do it, but it is the cool kids way to do it. It's like in the terminal. It goes much faster when you just say like git add dot and it saves all your files, you know? But yes, this GitHub desktop application does exist, and I recommend you checking it out if you're interested in more like a graphical representation of what's going on with Git. Yeah, and it's directly linked to your GitHub, so that kind of connection is easy. So note, a lot of IDEs have Git integrations. That is actually the the text editor today that I showed you guys. This Atom text editor is developed and published by GitHub. So it has all this Git features built into it. And you'll see it's super small on your screen, I'm sure. But down here, it's like GitHub has like this publish, this Git, all this GitHub related information in the lower right. Atom is a free text editor. I really like it. But yeah, you don't need to have Atom to use GitHub. Well, thank you guys for spending time with me on your Sunday evening. I hope that some of you guys join it soon too, just to kind of advance yourself as coders or even as lawmakers or whatever you want to use it for. It's a great tool. Yeah, thank you all for coming. And enjoy the rest of the Learnathon.